Hey everyone, Avery Hagleitner here, and Beth Jubera. Lynn mentioned we are software developers on the Dynamic Cubes team, and welcome to the second part of modeling, deploying, and optimizing your Dynamic Cubes. So just to recap, the goals of this session, they are, in the last time I provided an overview of the Dynamic Cubes technology. Some of the other goals of the session are to learn the typical application lifecycle, and we're in the middle of going through you experiencing or seeing a day in the life of the scenarios of working with Dynamic Cubes. Last week I went over an introduction of the Dynamic Cubes technology. Beth talked about the lab scenario and went through the first two lab modules. Did basic cube modeling for the historic sales cube, showed you cube administration, as well as running a few reports to show that the cube model was deployed properly and reports are returning. Today, we'll start by optimizing that historic sales cube for performance by using aggregates, so securing content, and we'll explore combining two cubes into a virtual cube to implement the historic recent scenario for low latency. Okay. So this slide here is a reminder of the Dynamic Cube lifecycle. First step is to use the Cube Designer, the Cognos Cube Designer, which is a built-for-purpose modeling tool for dynamic cubes, to model and publish the cube to the content store. Once the cube definition is out in the content store, you go into Cognos Administration, deploy your cube, manage it, start it, so that once you start the cube, it's up and running inside the Dynamic Cube server, which is part of the query service. At that point, once the cube is started, your users can go into any of the studios, any of the Cognos studios, and run their reports and analytics, which go against the Dynamic Cube. And I'll show you today, when we start doing some optimization, the queries can go to a workload log that will then be used by the final step, which I'll show you next, which is optimizing your cube for performance by using aggregates. So we'll go into Dynamic Query Analyzer and do that. All right, and so that's basically the whole Dynamic Cube lifecycle: model, deploy, run your reports, optimize, rinse and repeat. So going over the lab modules again. So like I said last week, we created the historic cube, administered it. I will go through some of those steps really quickly again as a reminder, but then I'll start off with the next module, which is optimizing the historic cube. All right, so Aggregate Workflow. So as I mentioned last week, one of the main ways we get performance are through our aggregate cache as well as database aggregates. And the way to get aggregates into our system is to run the Aggregate Advisor. Aggregate Advisor is a tool that's part of Dynamic Query Analyzer, which takes the cube model, in our case it'll be the historic sales cube, as well as a workload log that captured actual user queries. So the Aggregate Advisor will take the cube model and the workload log, process it, run through its various heuristics and strategies to determine aggregates that we think will improve performance. And it can recommend both in-memory aggregates. So these are the aggregates that will be loaded after the cube is started up into the aggregate cache. And it's a real easy two-step process to getting your in-memory aggregates applied into the cube model. You just click Apply. It saves that definition to the cube, and the next time your cube is started, they will be automatically loaded. For the database aggregates, or the summary tables, you give a file, which we'll show you in the next module, a text document with a description about the database aggregate tables for the DBA to create. Once those tables are created, you go into Cube Designer, model in what we call aggregate cubes into the Cube Designer. This is to let the engine know that these summary tables, these aggregate tables exist, and so that we can guarantee routing to those aggregate tables. And then finally republish the cube model with those new aggregate cubes modeled and mapped in the model, and restart the cube. It should be good to go. So let me show you that here. So I'm going to open up the file from last week with the initial modeling. This is the model that Beth had created for the historic sales cube. Remember, the historic sales cube doesn't have any aggregates with it yet. It has 5 dimensions as well as several measures in a measure folder. So make sure we publish that. I'm going to select all these options. Go into the Cognos Administration. With Dynamic Cubes being an extension of Dynamic Query, it is built into, you can use the Cognos Administration to manage anything related to Dynamic Cubes. So here it has the historic sales cube that we deployed to the query service. So first thing we'll do is we will enable workload logging. This is the first step in terms of capturing information about user queries for the Aggregate Advisor. So let's properties on the cube. Here we will enable workload logging. I'll check that box and click OK. All right. So now workload logging is enabled. I'll start the cube up. All right, the cube is now available. On the right-hand side are some metrics showing the cube state. The state is running and good to go. So let's run some reports so they get captured inside the workload log. So here I will run those same reports that Beth had run last week. I'm going to run this region by product, brand by year, month report. First report takes a little bit of time just because my session is fresh, and the first report that ever runs against the query service needs to initialize some parts of the engine, so it might take a little bit more, a little longer than you maybe see. But subsequent reports after that should be a lot faster because you don't have to do the initialization again. So yeah, that's that report. Let's run this other report, year by product line. That was really fast, see? Didn't have to do that initialization again. Yep, and so we noticed that there is no slice, no dark green for mountaineering equipment. Let's drill down into that, take a quick look, see if there's anything funky. Yep, it just looks like maybe mountaineering equipment we just started selling in 2012. All right, so that's that report. Let's run the third report, promotions by region by quarter.
Avery, just a question about those reports and the data that's being gathered. So when you clicked on the details there, is it workload logging that activity as well, or is it just the report bringing back data? So I'm just wondering, like, what is that workload logging part capturing? Is it capturing everything you're doing in the report, or is it just capturing?
Oh, that's a good question. Okay, so what does the workload log actually capture? So the workload log captures information about the report that the engine processes. Basically anything that requires a retrieval from the database or a retrieval from the caches. Let me actually, I want to take a peek under the covers. I'll show you where that file is and what's in there. Would that help?
Yeah, I think so.
Yeah, okay. Let's go under to where Cognos is installed, under logs, XQE, rollup cubes, historic sales cube, rollup, or workload logs. Let's take a look at this. Let me open it with no editor. Okay, but not that one. Bear with me. We're kind of going off script, so let me just double click it. Nope. WordPad or something. Or something better. Is that a log file with things in a while, or is that a... Okay, well, it's a little easier to read here, but basically it's XML. It's not meant to be human readable, but you can, let's quickly scan to see what elements we have in here. So here we have reports, So we captured what report, the report name that's being run, when it was run, what measures were part of that report, also what dimensions, hierarchies, and levels were requested as part of that report, as well as maybe some key members that might have been requested as part of the report. So as I mentioned, the Aggregate Advisor takes the cube model as well as this workload log information to kind of come up with some aggregates one can recommend. So all these aggregates are based on certain slices, or a combination of different levels from different hierarchies, as well as a combination of measures. So by capturing this information, we know that, okay, well, this must be, if the region by product brand by year month report was run often, or if another user were to run similar reports that also used the measure profit and level year and product brand, we know that that's a very popular slice, or a very popular part of the cube that we might want to optimize. So that's a quick glimpse into what actually gets captured when we run reports with workload logging enabled. Does that answer that question?
Yeah, I think so. So if I understand correctly, so it's logging when you run the report with all that data that's being created or reported on, but it's not logging like when you're clicking around and drilling in and stuff like that.
Oh, yep, it will too. It sure will.
That's okay.
Yep. So actually, good question. So any user action that results in a query will be captured. So when I clicked on that mountaineering equipment drill down, that is captured as well. So ad hoc reports, dragging, dropping, drilling down, drill through, all that sort of thing. Any query that results that comes to the query engine will be captured.
Okay. So I guess the thing is that you want to do the actions, the most common actions that you, as a user, would be doing when you're looking at reports in order to capture that part of it, right? You don't just want to generate the report and that's it.
Exactly. Okay. So let me go through the Aggregate Advisor, and I'll show you some parts of that wizard where you can pick and choose what reports and what actions you want to optimize on. So that's the key point. You want to, whatever you capture in your workload log, you want to make sure that that's a representative workload, right? So if you know you have a set of canned reports, or a set of reports that your VP runs all the time, run those reports with workload logging on so it gets captured. That'll be part of your quote-unquote representative workload. Or if this is out in the wild and someone says, hey, my report XYZ is running really slowly, you can turn on workload logging, run report XYZ, and that information will be captured as well. So basically, it's a tool. It's a way to capture what we want to consider a representative workload, or a workload that you want to optimize. Yeah?
Yeah, thank you.
Good question. So we run that. You saw the workload logs being generated. So let's open up Aggregate Advisor. Aggregate Advisor is part of the Dynamic Query Analyzer. For those of you who have used Dynamic Query Analyzer in the past, you might have used this to take a look at query performance individually. So, but new for 10.2.1, fixback 1, so I guess that's 10.2.1.1, the Aggregate Advisor is now the main feature of the Dynamic Query Analyzer. So you'll see the layout, the view, the toolbar, and all the menu actions show the Aggregate Advisor perspective by default. So here, notice that the Advisor Results view is on the left-hand side. The Advisor Results view contains results from the Aggregate Advisor's most recent runs, as well as the history of previous runs. Basically, a summary of those runs are listed here, so you can do a quick comparison. So in this case, we have 3 previous runs that we did before. You can double check. So let's run it. So you can either go to File, Run Aggregate Advisor, noted by the Aggregate Advisor icon, or click on the toolbar button to run the Aggregate Advisor. So I'll click the toolbar button to launch that wizard. This first wizard panel is where you would select the cube you want to optimize. So we'll select historic sales. I'll click on Next. And here are some general options for running the Aggregate Advisor. So new in FixSpec 1, so new in 10.2.1.1. There are now 3 options to choose from under the query workload information section. By default, query structure and workload information is selected. This allows the advisor to use both the workload log as well as doing structural analysis on the cube model to come up with recommendations. For this demo, we will choose query workload information only, so that the advisor uses only the workload logs that we just enabled earlier, and this also means that you get a shorter amount of time to run the Aggregate Advisor, which means that the recommendations that we get are focused almost completely on the workload and minimally on other areas of the cube that may be used in an ad hoc query environment. Okay, so we'll keep all the other defaults. You can choose, how much memory to give to your in-memory aggregates. This is the sum total of memory for the in-memory aggregates. How much memory you want to give to the database. Keep in mind this is a rough estimate of the uncompressed size of the database aggregates. And also you can give it a time limit. So these are all good for now, so we'll select query, workload information only, keep these defaults. That's fine. We keep these defaults because with our sample data here with Go Sales, it's pretty small. To determine what appropriate values to put here, we recommend looking at the hardware sizing guidelines or hardware sizing recommendations that are out on Developer Works. And we can provide those links at the end, or you can just do a web search for those terms. Dynamic cubes, hardware sizing recommendations. I think we're the first hit. All right, so that looks good. Let's click on Next. So here, what it's doing is it's actually going back to the server side to collect that workload information from that log file, compile that information, and bring it back here. So here, you can actually filter your reports to focus where you want the optimization. So last week I mentioned, maybe if Beth were my VP, I want to make sure her reports are really fast. I can click on usernames and choose only Beth's reports. Or if I wanted to optimize only the reports between Monday through Friday from 8 to 5 p.m., I can do that too down here below. So for this demo, we will choose report names. I'll click on this. You'll see the names of the 3 reports that we just ran are listed here. And something a little extra. So what we'll do is select all 3 reports here. Click OK, and we'll click on Finish. So what shows up here is the status dialog. This will show the advisor's optimization trend. So for larger cubes, this is a really small cube, and we chose to use workload only. But for larger cubes, this can take some time. So you can use this unit list graph to determine when you want to stop the advisor early. You'll see that the end button is enabled right here. And also finish really quickly. But I just want to mention that the advisor can run for some time if you do choose to include workload as well as cube model analysis. That's because the advisor goes through several heuristics, several strategies in determining its recommendations. And after the end of each strategy, after each iteration, if you will, it has a set of candidate aggregates. And so we recommend run until completion. So basically, the longer you let it run, the better the recommendations will be. You may also notice for a graph that runs for a long time, at the end of each of these iterations, these heuristic strategies, you'll see the graph spike up. And that means, okay, yes, we're done with a major iteration, and it'll continue. If it runs for a long time and you see the graph kind of leveling out for a while, it still could be churning within one of the iterations, and you may choose to click on the end button to stop the advisor and get the recommendations that it has so far. But like I said, we do recommend the first time you do run the advisor that you let it run to completion, let it finish all its different strategies and so forth, so you can get the best recommendations that you can get. So, okay, so here you'll see that the recommendation, the run that we just did shows up on the advisor results pane at the top. And I just want to mention, if you had used the dynamic cubes in 10.2, you'll see that in this new version of 10.2.1 that the advisor has improved heuristics for recommending better aggregates to improve the coverage of the cube, as well as introducing sampling as part of the advisor queries so that the advisor queries can run faster and do more experimentations with different candidates. It's probably part of the reason why it finished so quickly. Okay, just wanted to show you one cool new thing that's part of Fix Pack 1, which is you can set a description, the description name for your Aggregate Advisor runs here. So you just select it, you can choose a name, whatever you want it to be called. Demo. Okay, let's open up the file. Okay. So here this is a 3-tab editor pane for the recommendations. So in the General tab, it basically shows you a list of the in-database and in-memory aggregates. So it recommended 1 in-database aggregate and 4 in-memory ones. Also gives you some other summary information about the estimated size of how much memory each of these may take in total. The second tab in database shows detailed information about the database aggregate recommendations. So you'll see at the top there's a section that talks about what options were given when you ran the advisor. In our case, we ran it with the workload only. It shows the options for the sizes as well as what report filters we ran it with. Here's some more descriptive text for your modeler or your DBA. This file is meant to be given to your DBA first so that they can create the database aggregates. And once those tables are created, this file can be given to the modeler to finish up modeling the aggregate cubes. So let's take a quick look here. I'm just going to skim it. We're actually going to save this file off and take a look at it in Notepad. But you'll see here it recommended 1 database aggregate with product brand, promotion name, region by day, levels, and all the additive measures here. Down below is an example SQL that the DBA can use as a guide to loading the aggregate table. That's that. So let's save that file. So we'll save in database recommendations. Save it to the desktop. I'm going to call it Historic Sales Database X. Let's go back to the General tab. We'll see that we have 4 in-memory aggregates here. Let's apply them. So all you have to do here is click on File, Apply Selected In-Memory Recommendations. So when I click on this, this will save the definitions of those 4 in-memory aggregates to the content store and associate it with the historic sales cube. So something that's new in Fix Pack 1, so 10.2.1, is the ability to select individual in-memory aggregates to pick and choose which ones you want to include. Previously, in 10.2, you had to save all of the in-memory recommendations to your cube. For this demo, let's just select all, keep that going. So click OK. So here we have a warning. This is a dialog to just remind you that the historic sales cube that we have is currently configured to use 0 megabytes for the in-memory aggregate cache. So what we need to do next is increase that cache limit before restarting the cube so that the in-memory aggregates can get loaded. So if you don't do that and you keep the aggregate cache size at 0, it will ignore any of those definitions that are associated with the cube and not load any aggregates into the cache. So, but we'll update that setting, the maximum amount of memory to use for aggregate cache, a little bit later. Okay, so I'll click Accept. So it'll save those definitions out. So I'm going to close this here. Let me open up that text file again, or open it in Add. Better. Okay. Okay. So you would give this file to your DBA to create the database aggregates, and we've already created this table in our database. So let's just take a look quickly on the side here. So now what we're going to do is we're going to model the aggregate cube in Cube Designer. So going back to Cube Designer, I'm going to try to do a side-by-side view here. Show you how easy it is to use the information that's in this file to model your aggregate cube. So we're here in the historic sales cube. There's a folder here for aggregate cubes. I'll double click on that. So let's click on the new aggregate. All right, let's create a new aggregate cube. So first thing you're going to do is you're going to select the measures and the dimensions that are involved in the aggregate table. So let's look here on the left. Looks like we got quantity, sale total, profit, unit cost, unit price, unit sale price. And the dimensions that are part of this aggregate are, so the ones that are not at the all level, so below the all level, we have product. So let's select product. We've got promotions, we got retailer, and we got time. Okay, click on that. All right, let me make some more room here. Double click on that aggregate cube. All right, let's first rename it. I like to give it a name that kind of relates to what the aggregate is representative of. So I'm going to call it Agger. Brand. Promo name. There seems to be something cute. All right, so we renamed it. All right, so under the dimension column, we'll click on product. You'll see here on the left-hand side, or sorry, stage left, the right-hand side, that you see the hierarchies for the product dimension. Let's check some boxes for what the level of aggregation is. So looking on the left-hand side in WordPad, looks like we have product brand in the product classification hierarchy. So let's select that. You can see when I select that level, all the levels above it are also selected. That this is required because we need to be able to roll up and route all our queries to higher levels of aggregation here. So by selecting brand, it also selects the ones all above it. Okay, so let's do the same for all the other dimensions here. So promotions, then the promotions hierarchy, promotion name, select that. All right, retailer, retailer hierarchy, region, select that. Time, and time hierarchy, day level. All right, great. So now I've modeled at what levels of aggregation each of the dimension hierarchies are at. I've included the measures. So the next thing to do is map it. Map it to the columns in the aggregate table. So what we're going to do is go on the left-hand side here in the data source view. Open up the tables. Here we have that aggregate table that was created. Expand that out. All the different column names. I'll click on the Key Mappings tab, and it's just an easy drag and drop here. So the one nice thing about the Aggregate Advisor is that it will recommend aggregate tables structured in a way that makes it very easy for you as a modeler to associate the columns and the attribute level keys and all that. It gives you everything that you need as part of the aggregate table definition. All right, so I'm just going to drag and drop. It's really simple here. I mean, it's easy to read. Okay, promotion keys, promotion key, region keys, region keys.
And Avery, there's also a auto-generate for these aggregate tables as well, correct?
That is correct, yeah. So I could have dragged that table, this aggregate table in, dropped it into that area, and it would have automatically figured out, did its best guess on what levels of aggregation, what keys are involved, what measures, and so forth. I'm showing you the manual way so that you can see what actually goes on underneath the covers and what is part of modeling an aggregate cube. So that's the identifying what measures and what levels of aggregation, as well as making sure that the mappings are all correct. And one more. Okay. So now we've mapped the level, the key mappings for the level keys. Let's also do the same for the measures. So go back to the Editor tab, click on Measures, and from our data source view, we'll get these columns. You'll see it's really easy. You're just going down the line here. So it is worth saying that this is really easy for any of the aggregate tables that were recommended by the advisor. You can also model in any existing aggregate tables that you do have. So it's the same process as I showed you here. Probably I would recommend going through the manual steps so that you know what you're actually selecting, as opposed to letting auto-generate figure it out, especially for your existing aggregate tables. Okay, so that's all modeled, mapped. Let's do a validate on that. See if I did all. All right, looks like we did. So I am, you know what? Just in case I might have misclicked something, I'm going to open up the point file here. Okay. Has our aggregate table with all the mappings and so forth. Okay, so let's deploy this cube. Or publish it. Okay. Here, publish the new definition. Okay. Very good. And that's that. So now your historic sales cube has aggregate cube as part of the definition. We had saved or applied the in-memory aggregates also into the content store from DQA. So let's go into the Cognos Administration. So the cube is up and running right now. It is running with the previous definition of the cube without the aggregate cube or any of the in-memory aggregates. It's only when you restart the cube that the definitions are reread. So for this running instance of the cube, you'll see on the right-hand side that it does have 0 in-memory aggregates defined against it. The in-memory aggregate cache was set at 0. There's nothing in that cache. Is there anything else you wanted to?
The in-memory aggregate cube hit rate is 0%.
Mm-hmm. Right here?
Mm-hmm.
Yep. Because there are no in-memory aggregates in the cache, it's all 0. So we'll take a look at that when we apply that, and you'll see that that'll go up.
Keeping us honest.
Yeah. Yeah. This is the before picture. Everything's 0. So that's set properties. Okay. So on the cube, there's this maximum. Oops, not this one. Maximum space for in-memory aggregates. Right now it's set to 0. What do we set this to? If you don't remember, we can go back to Dynamic Query Analyzer, this one, and take a look. So it estimated it required about 1.9 megs or so. It's not very big for all 4 of them. So when I go back to here, I'm just going to give it a lot. Not more than you need. 128 megs. Doesn't really matter. So go ahead and save that. Actually, you know what? One thing additional that I will do that I forgot is I will disable workload logging. I don't need it anymore. I've captured my workload, my representative workload. I've run the advisor on it. There's no need to keep capturing reports right now. So I've disabled that. I've set the aggregate cache size to something larger. And at this point, I will restart the cube. Okay. So restart will do a stop of the cube, start it back up, reread the definitions, and load the members as well as the in-memory aggregate definitions. So here on the right-hand side, you'll see that now it's 0 out of 4. So yes, hey, it picked up that it knows that we have those 4 in-memory aggregates that we defined. And we'll click on refresh here. Maybe I should have clicked on refresh as we're loading it, but now it's all done. 4 out of 4 of the in-memory aggregates are loaded. You'll see down here that the used over defined size in cache, about 0.8 megabytes of the 128 we've allocated have been used. Also, there's another metric here, time spent loading in-memory aggregates. It was really fast. It was just about a second for this very small database, or very small warehouse cube. Let's see, what other metrics are interesting here? This one here, aggregate table hit rate. This one's 100%. What this means is that the 4 in-memory aggregates, the queries that were used to load those 4 in-memory aggregates actually took advantage of and were routed to that aggregate table that we just created, which is great, which really accelerates the load time of those in-memory aggregates. And that shouldn't have been a surprise, because if we had looked in Dynamic Query Analyzer, or actually, let me show you in my notepad, the other notepad, that this database aggregate, there's one piece of information here, it's kind of nice. Down below is that the number of recommended in-memory aggregates that this aggregate can cover, 4. So this is pretty cool. This shows us that if we had since we did implement this database aggregate, that 4 of the in-memory aggregates that were recommended as part of the same set of results, same recommendations, could be satisfied by this database aggregate. So that's why that table, or that's why that metric shows as 100%, and that's what we want. So now let's rerun some of those reports and take a look at those metrics. All right, let's go back to our Cognos content, to the lab, and the historic sales reports. So let's run this first report again here. All right, that was fast. So let's look over here on the metrics, refresh that. You'll see here that the data cache hit rate is up. It used the data cache a little bit, as well as the in-memory aggregate cache hit rate is now 100%, meaning that the queries that were posed by this report did, in fact, use the values that are in the aggregate cache that we already have preloaded. So that's pretty cool. Let's go back. Let's run the second report here, year by product line. That was fast. Look at the metrics again. See, nothing really changed. Again, this also was a 100% aggregate cache hit. I'll run this last report here. Refresh the metrics. Still 100%. So let's run some more reports that may either miss the aggregate cache or go to the database. So let's run this report, check the metrics. You'll see here that the data cache hit rate went up a little bit, meaning that it hit the data cache. And let's run this last report here. This report, I believe, should miss these caches. So we hit refresh. Yes, okay, it actually does reflect actual values. So the in-memory aggregate cache hit rate is now 99%. It did spend some time in the database getting those values. So that's all I really wanted to show here in terms of the aggregate workflow. Okay. All right, so that's that. I want to turn it back to Beth now to continue.
So I'm going to talk about security and the security options that we have for dynamic cubes. So last week we discussed about how security works in dynamic cubes. One benefit of dynamic cubes is that we have this concept of shared caches. So the data cache, including the member cache, the data cache, and the in-memory cache, are all shared across users. And so this means that we don't run queries against the warehouse specific for a user. When we query the database or the aggregate tables, those are run generically. So we're always getting the same value for a particular tuple in the database. How security comes in is when you run the query, we actually filter the data that's returned from the cache based on the user's security levels. So if you're restricted from seeing the West Coast region, you'll only see you won't see those members or their data values. But the cache values, you're still pulling that data from the cache, and that makes our processing a lot faster because we're able to leverage that same cache across all users. All right, so how does security work for dynamic cubes? So good or bad, we have a lot of security options that users can use. And so what we've seen is that users tend to have a way of securing their system. They're either granting members or they're not restricting members, or but not usually a combination. So we give them lots of options depending on how they like, what their preference is. And we also have a number of different things that you can secure. The first being member security. And this is what I just referenced, where maybe you can only see the customers in America. Maybe you're a product line owner. You can only see the products that you manage. That would be member security. So that restricts, when you run the report, you might only see North America, while my coworker in France only sees European. The other security, we have secured measures, so you can see a limited number of measures. We have the ability to restrict dimensions, and we also have the ability to restrict level attributes. Okay, so how do we do this? The first thing you do is for that member security, if I only want to see North American retailers, I can define security filters on a hierarchy. And there's two ways I can do this. I can either secure it based on a V5 expression and actually call out those members that I want to create a security filter for. For instance, Americas, Asia, Europe. Or I can use lookup tables, which are, I would say, 90% of, maybe 99% of what we see in our customer scenarios, where we're leveraging their already existing control tables that someone is managing. And we use those to determine, based on the user running the report, what either products they can see or retailers they can see, or whatever their security structure is. After defining the security filters on a hierarchy, you construct the security views. This can be a combination of hierarchy security filters on the members and then also the dimension, measure, or attribute restrictions. The filters and security views are defined in the cube designer. Once you've made these security views, you would republish the cube or deploy the security-enabled cube with that new security information. Once you've deployed the security-enabled cube, you'd go into your Cognos Administration, and those views will show up similar to the common Cognos security structure that you're used to seeing, where you go in and you have access to the Cognos groups or your LDAP groups, and you can specify which users are assigned to those views. So if you have a North America group in your LDAP system, you can assign that North America group to your North American restriction. If you're using lookup tables, you can assign everyone who would be in that lookup table so that any user that comes in is going to use the lookup table. You do need to refresh your either restart your cube or refresh your security settings to have those then be picked up on the published cube, similar to what we did within memory aggregates, where once you make that change, we need to pick it up. So, okay, let's get into security. I'm going to start where Avery left off here in our historic sales cube. And the first cube, and I'm going to go through the different security options. This is unlikely that a customer would actually use all of the security options we offer, but just to give you an illustration of what you can do. So first off, I'm going to look at the region, or the retailer dimension, retailer hierarchy. And I'm looking at the security tab in the retailer list. And I'm going to create a new role security filter. And a role security filter is the one that uses the V5 expression to define members. So under my retailer dimension, I can open up my member browser tree. And this first security filter I'm going to create is going to be, let me rename this here, and I'm going to call this my Allow America's Region. Okay. And I'm going to, I have my member browser here for my retailer dimension, and I'm going to drag in, edit my security expression, and I'm going to drag in my America's member. Okay. So my scope on the members that are in this filter, or in this expression, I have an option of what I want to do. So I can, again, we give lots of options. So in this case, I want to grant members that I've defined, that I've explicitly stated their descendants and their ancestors. I want access to that whole tree. Okay. Valid, okay. So now any user that has access to the security filter is going to have access to the path of America. So Americas, the all region, and any children of Americas. I'm going to create another security filter. I'm going to call this one Deny Europe. And I'm going to create a V5 expression on this one, and I'm going to say I'm going to deny Central Europe, I'm going to deny Northern Europe, and I want to deny Southern Europe. Okay, and my scope for this one is actually going to be deny members and descendants. So this is going to cut off the whole tree underneath Central Europe, Northern Europe, and Southern Europe. So any user that's assigned to a view with this filter won't be able to see these members or their children. Okay. So next, we're going to look at, so these are the role-based. These are where we're using the V5 expressions to define security roles. We could also use filter expressions, like you only want to see members, retailers that have sales over a certain amount, or any V5, valid V5 expression that would return a set of members in the hierarchy that you're defining members over would work. Okay, next I'm going to use the security lookup tables, which again are the more popular method. So here's a security lookup table for the product dimension. And one nice thing about having this Data Source Explorer in Cube Modeler is that we have a live connection to the underlying database. So I can right-click here and view data. So I want to see what's actually in our security lookup table. Okay, so in here I have two user IDs. I have a user ID column, a product line key column, and then the corresponding name for the product line. So depending on what your customer scenario is, this would be our user ID from our LDAP listing, the product line key, and our product line. So in this case, the user Waters SJ, let's say, only has access to product line key. He's in charge of camping equipment and golf equipment. I like that. Those are good things to be product line owners for. Myers has personal accessories and outdoor protection. So let's see how we would map, how can we leverage this table to restrict that when the user Waters logs on, he only sees camping equipment and golf equipment. So the first thing we need to do is make the query items in the security lookup table available to the rest of the system. So we're going to go into historic sales. We're going to say into our model. We're going to create a new query subject. And this is going to be our, what are we going to name this? I'll just use the same name. Okay, double click. And I'm going to drag in the table I'm interested in. And now I have access to these elements. Okay, so now I'm going to go into the product classification. We can see that here's our product classification hierarchy definition. So we have these 5 levels. And if you're wondering how this all came to be, we have this recorded. I went through this last week in our first session, and it's all recorded. And so here I come into the security tab for the product dimension, and I'm going to create a new lookup table-based security filter. And let me I'm going to call this grant product lines by lookup. Very, very useful. So how am I mapping? What is the mapping between our level keys, the unique identifiers for members in the hierarchy, to that security lookup table? So we're going to map our product line key. Oops, that's not a drag and drop, that's a drop down. So I'm mapping the product line key to our product line key. All right, that sounds good. Here's our security lookup table that we're using. And I want to grant, again, that scoping option. I want access to the members, descendants, and ancestors. Okay, so how do I now, I've mapped the product line key column to the product line in our hierarchy, but what about that user logon? So this is a little trickier, and this shows your knowledge of LDAP. So you would need to know about your LDAP system or whatever authentication or security provider you're using. You could also use the Cognos groups if that was your way. But I'm going to drag in the UUID, and this table needs to map whatever that macro expression is. I'm not a security wizard, so I'm going to copy the expression as I know it to be. So this is using the macro expression for that username that logs on. So when I log on as Waters SJ, it's going to know to do that mapping. I'm going to validate. Okay. So now we're all set with our grant product lines. Okay. Okay, so now I've got my security filters defined, and the next step, as I mentioned earlier, is to create the actual security views. So I'm going to create a new security view, and I'm going to call this new security view Access America. Okay, so in the security view, I can do a combination, as I said, of member security filters that I've defined. I can secure measures, I can secure dimensions, or dimension attributes. So in this case, I'm just going to add to the security view the retailer allow America's region that I defined earlier. And that's going to be it for that view. I could create another view. Call this one secure order. This is going to be a little verbose, but secure order method, retail type, other, and Europe unit cost. Okay, so in here, and again, depending on your customer, they're probably not going to use all our security features, but just to show you what we have available, this is the retailer deny Europe. I can come into my measures. I'm going to secure unit costs. I'm going to say deny unit costs. Anything not denied will be granted. Go into dimensions, and I'm going to say deny order method. I'm going to go under my dimensions attributes. Retailer has a retailer type related attribute, and I'm going to deny that. Okay. All right, so last but not least, I'm going to create that lookup, the lookup table view. I'm going to say this is grant product type by lookup. And this is going to use the product classification filter on the lookup. Okay, great. So I've got my 3 security views defined, and I'm ready to go. So I'm going to republish the cube. And, okay. I'm going to come back into my historic sales. I'm back in the Cognos Administration panel. We have the option of refreshing security settings. So if the only thing I changed was security, I don't need to do a full restart of the cube in order to pick up the new security settings, because as we said, the dimension cache and the data cache and memory cache are shared across users. So it really doesn't matter what happens at that security level. The caches can all stay the same. Now, if you're making any other changes, if you change really anything. If you're changing member names or anything else in the model, it requires a restart because we're reading from the model out of the package, and we want everything to stay in sync. And if our security settings go out of sync, things go bad. I'm going to restart just to make sure we're clean, but we would, well, actually, we'll get a warning if we can't restart it. But so let's view our recent messages. So security refresh succeeded. If I had done anything other than adding security, it would have told me that I needed to do a cube restart to pick up security. Okay, so next step, if we go back, think back to our life cycle, I've created those views, but what do those views have to do with our authentication? So I'm going to go under, so I've got my historic sales cube, and if I actually need to back up oops. Sorry, data stores. I'm looking at my historic sales cube. And I'm going to edit my security view permissions. So now I see that the views that I had published for the cube. I have Access Americas, grant product type by lookup, and secure order method. So I'm going to go under Access Americas. And for anyone familiar with security, you know that by default you have, well, there's certain defaults for your security views, and we need to update those because right now, by default, you have the everyone in this view, which isn't what you want, because if everyone has access to Americas, everyone's going to have access to Americas, which isn't necessarily what we want. So we're going to go in here and we're going to look at our LDAP users. And I'm going to show users. And I'm going to add Waters SJ. And then I'm going to remove everybody else, and then I'm going to give. So now when Jeff Waters logs onto the system, we're going to say, what security views does Jeff Waters have access to? We're going to say, oh, he's part of Access Americas, and we'll give him access to the Americas. If I go into Secure Order Method, this is the one that restricted the okay, and I'm going to add, who am I going to add to this one? I'm going to add Tim Myers to this one. And Tim Myers now has access. And grant product type by lookup, I'm actually going to keep the same because this one was a lookup table. So anyone who comes in can have a lookup table. We want anyone who logs in to have to go to the lookup table to see what products they have access to. Okay, close. Okay, and actually I'm going to refresh security again just to make sure that we pick up the changes, even though I don't think we need to do. Okay, so now I'm going to go under, okay, so just to refresh, well actually we've seen this already. I'm going to log off, and I'm going to log on again as one of those secure users. So I'm going to log on as Waters SJ. Okay, and he's not an admin. As we can see, we don't have access to the admin console. And I'm going to go under historic sales, and I'm going to run my region by product, brand by year, month. Okay. And as you can see, all I can see is Americas. I don't have access to any of the European or any other values. So looks like our retailer restriction for Access Americas kicked in. Year by product, that one didn't have any product information, but now if I log on as product and to view the product line over time, Jeff Waters is the one I liked. He's got camping equipment and golf equipment. Sounds like a good friend to have. I like that. So you can see that these values were restricted. You can't see those things. Okay, so now if we log on again, we're going to log on as Myers. What's his name? Myers ST. And oh, actually. actually, Myers with T. I'm going to open up Report Studio, and I want to see what historic is. Oh, actually, well, okay, so in this case, Myers with T was assigned to the view that had all that stuff, all the measures and the dimension attribute restricted, as well as his lookup table for product was different than, his entries were different than Myers was. So as you can see, I don't have the order method dimension shown here, so no access to that, and I don't have access to the unit cost measure. If I look under product, my product members, I only have outdoor protection and personal accessories. If I look under retailer, I only have access, I don't have access to the European areas. And if I look under retailer, I'm missing the retailer-related attributes. And if I ran these reports, if I ran the reports similar to what we had run earlier, I can't run that one because he's missing unit cost, because he doesn't have access. I think that's it for security.
All right, so we're at the last module. We're going to create a recent cube and create a virtual cube as well. So if you remember, virtual cubes serve two main functions. It's to, one, create a union of the members of the source cubes, and two, to merge the tuples that exist in both the source and merge those values together. So this can be used in a number of different scenarios. Last week I mentioned putting together multiple fact tables, bringing them together into a virtual cube, and I also mentioned this recent historic configuration. So if you remember from last week, the recent historic scenario is a low latency optimization that allows you to kind of utilize all the extensive caching that's involved, because we split the facts into two segments. Historic sales contains the bulk of the data, and you can keep the aggregates and all the caches warm and ready to go, because if your updates to the fact are only for the recent values, you don't necessarily have to update them and flush the caches as often as you need. If you separate it out to have the recent sales cube for the most recent changes, that since it's so small and representing a small chunk of the data, it can be refreshed more often. And by bringing the data into a virtual cube, any queries that come at the top at the sales level will be split across the historic and the recent sales. And because we have kept caches going for longer in the historic sales cube, of course, will run fast, and as well, any queries that go against the recent cube, since it's small, will also be fast. So let me go to a quick view of the modeling. In this scenario, all the dimensions in both the historic sales and the recent sales cube are what we call conformed, meaning they match in all ways and forms. So this is very easy to model, and I'll actually do that real quickly. But this is just a visual to show you how the virtual cube modeling editor will look. You have the virtual cube sales, the dimensions, the virtual dimensions there, and what the underlying source cube, corresponding source cube dimensions are. All right, so we have the historic sales cube. Let's model the recent sales cube. I'm going to do new cube. We'll call it recent sales. Okay, under recent sales, got measures. And on the data source view, we're going to get the recent sales fact table. Because as I mentioned, we're segmenting the facts for recent from the larger bulk data that's in the historic side of things. And in our case, recent fact table only contains data for October 2013, whereas historic contains data for everything prior to October 2013. Let's double-click to get into the editor for the cube itself, and let's drag and drop there. Easy. Done. Now, one of the nice features about the Cube Designer is the ability to share dimension definitions. So because these are fully conformed dimensions, we can just drag and drop these dimension definitions into the cube, into the recent sales cube. Done. That's it. That's all you have to do. Validate that. Looks good. Going to publish that. All right, we'll select the package for that. We'll make sure it's added to the dispatcher. I'm not going to start the recent sales cube just yet. I want to do a little bit more before doing so. So I'm going to click OK. Publish that out. Great. So now we have both the historic sales cube as well as the recent sales cube. Let's create a virtual cube. So to do that, up here at the top of the toolbar is a new virtual cube button. You'll see the icon's a little bit different. It's kind of translucent, representing a virtual cube. So let's do new virtual cube. This list shows the cubes that are listed or available within your project. You can also have the option to select any source cubes that are in the content store here, but in our case it's really easy. We have both of the cubes in our model already, so let's select both of those. Click OK. Let's name this sales. All right, let's double click on that and take a look. And you'll see, like I said before, that because the historic sales cube and the recent sales cube have exactly the same dimensions in them, they're fully conformed, it was easy to merge, to find the dimensions to merge upon to create the virtual dimensions. Now, if you were to combine multiple fact tables, maybe with different named dimensions, those would also show up here, but you also have the option to edit this at any point. So if one source cube has a dimension that you don't necessarily want to expose in the virtual cube, you can choose to remove it here or kind of modify the mappings here. What the auto-generate of the virtual cube does is it does a simple string comparison, order method, hey, those look like they're makes sense to merge together. But if you had another dimension that was named similarly but not exactly the same, it might have shown up as not conformed, but you have the option here to edit that and and kind of associate maybe a product and a product dimension together to form your virtual dimension. So that's all there. That's easy. That's really it for your virtual cube. One thing that I will do is I will rename the folder for the measures. What it does is it takes the folder name, the measure folder name from the first source cube that it's there. So I'm going to rename this to sales. Did you rename it on recent sales too? I don't know. You know what? One thing that I'll do, I'm just going to open up the checkpoint file since we're a little short on time. Yep, that was named recent sales. Yep, the folder is named recent sales here. I think that's it. Yep, I think that was it. So let's publish this virtual cube. Say that again?
I published that one and recent sales. I think your measures folder was named.
Okay. All right. This time with gusto, we're going to publish the recent sales cube again, just to make sure everything's good. All right. That's that. Let's publish the virtual cube. Did the same thing. I'll publish this with the package, add it to the default dispatcher, but I'm not going to start the cube just yet. I want to show you some stuff inside the Cognos Administration. Okay. All right, that's that. Let's go to the administration panel. Log off and log back in as the administrator. Go in here. All right, go to my data storage view. And here you see all three cubes. historic sales, which we already have up and running from before, recent sales, and sales. So I'm going to select sales here, and I want to show you the metrics for a virtual cube. You'll see that it's a little different than a source-based cube. And that's because the virtual cube does not have an aggregate cache, but it does have a data cache as well as a result set cache. One other metric that you'll see, so you won't see any of the metrics related to in-memory aggregates, so none of the time to load in-memory aggregates, or the aggregate cache hit rate, or the aggregate table hit rate. But you do have hit rates for the data cache and the result set cache. One additional metric that you'll see for virtual cubes is the source cubes metric to show you what are the dependent source cubes of that virtual cube. And here it's listing historic sales as well as recent sales. Okay? So let me go back to the data stores view, and I'm going to start, let's see.
Avery, just a quick question. Can you have a virtual cube that's based on another virtual cube?
Yes, you can. Yes, so a virtual cube can be made up of two, I'm going to call them base cubes, like historic and recent sales are. It can be made up of a base cube and a virtual cube, or it can be made up of two virtual cubes. So you can chain them together, if you will, into a multi-tiered structure of virtual cubes. The only restriction is that virtual cubes bring together exactly two underlying cubes at a time. Okay? Any other questions so far? All right. Cool. Let's start this cube. Yeah, I'm sure. Let's do it. All right. So you get a warning here saying that the recent sales cube is also needs to be started, and that's because for a virtual cube to be started, all of its source-dependent cubes also have to be up and running as well. So by clicking OK here, by clicking OK here in the admin UI, it will automatically invoke a start on the recent sales cube as well. So a little nicety there. And we got they're unavailable. Let's see what's going on. All right. Okay. You know what? Is that the same problem here? Probably. Model it from scratch. Okay, so something's funky with the model. That's okay. Let's go back to here. Let's double check what's going on. Let me delete all these measures, and let's go back to the recent sales back table, and we wanted quantity down to profit, shift, drag, drop. All right, so that's there. Should I recreate this? I'm going to delete the virtual cube, and I am going to recreate that virtual cube again, selecting, call it sales. I'm going to rename this folder to sales. Everything's conformed. Everything looks good there. So let's validate this. Validate it properly, so let's publish it again. Okay. Okay. Great. Let's validate that virtual cube. All right, no news is good news. Publish. Okay. All right, let's try this again. Take two. Go back to my data stores view. All. Refresh here. All right, let's do this. Try to start that virtual cube again. Yes, I want to start it. Yep. Please also start my recent sales cube as well. Okay. All right, that was quick. You'll see now that the recent sales cube is available and sales cube is available. So is there any metrics that I want to show here? All right, so virtual cubes also have the metadata load time associated with it, as well as the metric for uptime. So let's run some reports against the virtual cube. Okay, I'm logged in as admin. Let's go to my virtual cube reports and run. First, we're going to run a report for quantity, Las Vegas, for the months of 2013 against only the historic sales cube. Okay, as you can see here, this is run against only the historic sales cube, and as I mentioned before, the historic sales fact table only has data for all the months of 2013 prior to October. So you see here that the total for a query against just that historic sales is about 60,000, and there's no value for October. Okay. Let's do the same kind of query against the recent sales cube, or the recent sales fact table. The recent sales only has data for October 2013, and see here, it just only has that value here, and it's reflected in that total. Okay. And now, let's run a query against the virtual cube that brings together both the historic and the recent sales, and it merges all that metadata and merges those values into one. You see here, it's a complete picture. It has a value. It brought the value in for October 2013, as well as is reflected here in the total for 2013 at 61,000. There you go. So
The crowd goes wild.
yeah, wow, yeah. So that's it. That's how easy it is to use virtual cubes, especially with the recent historic scenario. How easy it is to model a fully conformed cube, bring together those in a virtual cube, and you saw how those values are put together in a virtual cube.